Okay. Then we tried solving this. This is a Twitter data, right? Then we cleaned up Twitter data. Then we had this class prior. We saw the impact of using it and not using it, right? Class prior. Okay. Then you have fetch. Then we did is a 20 news group using the data problem, right? Okay, so it was the first problem that we did. Then okay. So, any doubts on any of the previous topics? Today we'll start on the topic that is decision tree. We'll be able to follow actually without the previous thing. Folks online, can you see my decision tree notebook? Ganga Sajanya Sankalp. Is it muted? Maybe you can just text it. I don't know if it is muted or not. Oh yeah, not that GitHub. That's what I was saying. Is it fine now? Okay. Okay. Let's understand decision tree and why it is. So who here has played this game Damshads? Everybody has played the game Damshads. What do you do in that game? Basically, somebody asks a question. Right? Somebody's trying to think of a way and somebody asks a question. So based on the question, you predict the movie. Decision tree is nothing but, similar to that. If you're a good machine learning programmer, you'll identify the best questions. Got it, right? If you're a machine learning programmer, you'll identify the best questions. Okay, that's what they really say. It will be like Damstra's game only. Okay, your machine learning algorithm this time will predict questions. Right? It will predict questions for you. Okay, let's see.
This is classification.
This is used for both classification and regression. But mostly classification. Classification. So first you do First, let's actually, we had this iris data, right? Let's load that iris data example and let's see how to deal with decision trees. From scalar dot iris data datasets, import iris. Okay, so this is iris data, so we'll do yes. Go to load iris. Okay. Okay, you see there's 4 columns over here. This first column, second column, third column, fourth column. Right. Now, and what is your target? Your resource target, right? So this is basically classification data. 0, 1, or 2 is the target, and those are the 4 continuous columns that you have. So we'll now use. Okay, we'll now use your decision tree. We'll generate the decision tree. Remember, what is the idea of decision tree? The idea is to generate good questions, right? That is the whole thing around decision tree. You see the graph also getting created. So let me show the output, then I will explain it mathematically what is happening. Decision tree is equal to from scalar dot tree import decision tree classifier, right? This is the model. Decision tree is equal to dt dot fit is dot oops. Okay, so we have this. Okay, so decision tree is created. Where is the tree? What is, so this is no surprise, right? This is a basic loss function. We really want to see the tree that is generated, and what is this tree about? What is the concept behind it? You understand this. From scalar tree import export graph this to this export graph this. Okay, so what has happened using this line, right? These two lines, it has exported, it generated actually a tree. What will be the question here? I mean, okay, so this is the tree. So there is an website. Okay, there's a website where we can dump the content, it will generate the tree. Then I'll be explaining the other concepts here. This is a website name is web graph is. Go to this website. Okay, remember what is the file name that we have to create down? Okay. Oh, this is the file that got created now. Open this file in Notepad. Okay. If you open the file in Notepad, it would look like this. Control C, Control A, Control C. Copy the content. Okay, paste it over here. Control A, delete. We generate graph. You see this graph getting generated here? This is the tree which was generated for iris data. This is a small tree. 4 features. Exactly, and 150 columns. I'm coming to the problem part. Okay, first let's understand decision tree. You see here, what is this? X2 means column number 2. How many columns are there? 4 columns. If column number 2 is less than 2.45, if it is true, all these samples are your first class. Understood, right? Okay. Yeah. This first root. So here the important thing about decision tree is it should try to ask important questions. Okay. That's the important thing. It should try to generate important questions.
A few questions in this. So we just gave the data. It only decided what is the root feature. We did not tell it. And we can also explicitly tell also, right, to use this as a root feature.
No. Always. Yeah. Depending, if I give different data, it will generate different graph. If I change the order of the data, it will generate different graphs. I'm coming there. Okay, there are actually a lot of things I have to tell in those areas. Okay, I'm coming there. But here, let's understand what is this graph first. Then we'll come to those questions and a lot of internal things actually here are interesting things. So here you see this is the feature name. So that is what it generates internally. Using this decision tree algorithm, right? What it will generate? It will generate the right question. See here, this is the question, and all these are leaves. Understood, right? Leaves are the final closure. Like if you get a flower whose x2 is 2.45, less than 2.45, it will x2 means which is the column petal length. One of the features. I may not be right here. One of the features. If this is coming here, it means the flower is first category. Right? You can see all the flowers getting a first category. If it comes here, then the flower can be of second category or third category. Can you see this 50-50? Total number of samples is 150. Okay, 50 goes here. Similarly, if somebody comes here, then there are two possibilities. If anybody reaches any of the leaf, it means it is concluded. Okay, few important points to understand. There is a term here, Gini, 0.4. Right? So you can see here, Gini is 0.667. It shows the distribution of the data.
Ratio in each branch.
Yeah, kind of. Okay, you remember what is entropy? Physics class 7th, not physics, science class 7th. What is entropy of a system? Entropy of a system is a measure of randomness of the system. Okay, entropy is less means the system is very much homogeneous. Same data. Okay, so that's what here is. Gini is the measure of entropy. Okay, here you can see Gini is equal to 0. That means all the data are of same type. Gini is equal to 0.5 means 50% data is of one type, 50% data is of another type. Make sense?
So using this way, it predicts the
based on the training data, it will first generate the tree. After it has generated the tree, given a particular flower, it see this. If it is not matching, coming here, it concludes.
And from where it is taking this value? From our training data.
Training. Okay, based on the training, it is as simple as this. If I give you a lot of samples and you say, "Sir, this particular column, if it is more than this particular value, it is almost sure that this is this flower."
So any value it can pick.
Any value it can pick. If I run it again, you might see different TD also. Okay, so that is where I'm coming to the understood, right?
If we will give the test data, so it will try to fit in this model, means in this decision tree, and it will predict the
results. Okay, so here important thing to remember is if you pass data in different order, it will generate you different decision trees. Okay, if you pass data in different order, it will actually generate you different decision trees. That's the first thing.
How we decide that again the column x2 has to be taken as the first column. Like let's say I'm learning machine learning and I have a small data like 3 features and 10 rows. Maybe I want to make my own decision tree to understand the concept. So where should we start? Like how should I choose like which column should be at the top of the decision? Like here it is taken x2 as the
okay.
So in this case, right, and then it is split it to x. It is saying next we should take x.
Why are you getting? You're getting exactly same output, right?
Yeah.
This is because you are using the same order of data.
My question is like.
No, I'm just saying. Okay. Yeah, I tell you.
I mean, because I use same data.
Right.
So my question was like how it decides why the first column should be at the top of the decision tree.
Yeah. So what it does is, the decision trees, okay, it based on the data that is coming to it. Remember, it is all sequential training. One data comes first data that it comes to it, right? It sees, okay, and it has the target also. This is the data, this is the target. Based on that, it tries to identify the room. Okay, it tries to identify, okay, if this field, if you get, I suppose I give you this whole data, okay, and you see, okay, this type of flower is this. This type of flower is this. So it sees that if this column is more than, this column is equal less than this or equal to this, it is this flower. This column is equal to this flower. This column is equal to this flower. Right. So you have a lot of possibilities that it creates decision tree in the beginning, as you are saying. As it trains more and more, right, it brings important question in the top of the tree. Okay, so more and more questions you generate, it will try to get the important questions to the top of the tree. And what is Guinea doing here? Guinea is actually telling you what is the randomness of that particular data at this particular point. Guinea here is 0, right? That means there is no other type of data, only one type of data. Got it, right? Similarly, Guinea here is 0.5, so there is no other type of data, only one type of data.
Like other than 1.75.
Right? So X3 is less than 1.75. So if it is, what are the types of data which have it? It is 0.5. That is 50% data has less than, 50% of the data belongs to class B and 50% data belongs to class C.
Again, like there are 1,45.
1,45.
Just one level below.
This one.
Yeah. Here Guinea is 0.043. One of how it is calculated.
This one you're seeing 0.43.
Yeah, 0.04.
Yeah. So 1%, one divided by 46 will get this.
It's 0.02. It's double of that.
And some function of that, I guess.
Yeah, it's double of that.
Just do this maths. Suppose 100 samples are there, 46, and 50 by 100 is 46 1. Yeah, some function of that. Okay, I mean, if it is not coming exactly, see this 3 is there, right? 3 soda sample, 1 by 3 is 0.33. Some function of that, but it is almost equivalent. I mean, you can say it is equivalent. Okay, so that is what you are doing it here. This is Guinea. This is a number of samples which is matching this. This is how you generate a decision tree. Okay, there are a few things. I mean, these are okay, but there are a few things which are important to understand. If you change the order of the data, you will get different decision tree. You want to see that? So what you can do is
order.
This is the thing which is most important. You change the order of data, you will get different decision tree. Okay, you want to see that? So I can show that. So I have this. Okay, so what do you want to do? This is last. This is first 20, sorry. I want to add this to the last, bring it down basically. Right? Okay, np dot vstack. Right, this is actually shifted to 20 data is taken at the end. Move the data back. That's all we needed here. NP stack. So iris.
So are taking last 20 and first 20 rows. Is that right?
Adding last. What I'm doing here for last first 20 data, I'm bringing it in the bottom of it. Okay. See. Okay, you can see here, this also became reverse, right? 0, 0, 0. Iris target. Fine. Now I'll do the training part. Okay, so I've trained it. Export graph is dt out fine 3D dot. Okay. You can do these experiments actually only then a lot of internal things will be clearer. Unless we see it, it won't be clear actually.
Yeah.
Different, huh? Why is mine? I didn't copy it or what?
Mine is columns third first. Just taking third column.
Did it change or it's the same?
No, it's the same.
I think I didn't copy for some reason or.
For you it is. I copied your stuff.
Yeah, so GPV. Let me open it.
For me, third feature came first.
Yeah, now it is better, right? See, you can see the value also. X3 is 8. I think there was something wrong. I mean, I may have copied it. See, now it's a different tree altogether. So the order actually matters. The question you are asking, how did it learn? It actually learns based on the order itself. Okay, so one thing you understood from this experiment is that if you change the order of the data, your tree itself changes. Okay, and this is a very important observation here, because what is the guarantee there? I mean, it should not be the case, right? Different tree getting generated with different data. So this decision tree suffers a very important setback that is known as overfitting. Okay, what is overfitting? Overfitting means
it better result
on the training data compared to test data. Like what happens is, overfitting means what happens if you continue training with more and more data, the tree will become bigger and bigger. For this, but like like a bad Damsaraj player. What will he do? He will simply ask Cantino, is this movie this, is this movie? He might remember 1 million movies, he might ask for that. But is he a good Damsaraj player? No, because a good Damsaraj player will have very less questions. You have limited time to play Damsaraj, right? You have very less questions. Okay, so that's the whole thing. You have pretty less questions over here. I mean, in the sense that
we have learned like few classification techniques, right? So which one to use when?
I'll come to that. Which one to use and how do you make the decision making? I'll solve that using churn prediction. Churn. I mean, there is one problem that we'll take up, and we'll use that approach to learn it. But here, what you're trying to do here is you generate different trees with different data. This is what will happen now. So that is what gets into case of overfitting. Overfitting means your training accuracy will be very high. Your testing accuracy, I mean, whatever data you have trained with, that accuracy will be very high. But whatever test data you have, the accuracy will be low. Okay, that is your training and testing validation. So let me show it. And let me show some example of it also.
Overfit is when training data it gives high accuracy, rather than test data. It's less, right? And underfit is in training data.
Underfitting is less training has happened, less data, then so less training has happened. Okay, so so shortcomings of this is overfitting. Okay, we're running to overfit. Overfit means what happens if you overfit? That means the tree will become very deep. Tree becomes very deep. Okay, tree becomes very deep. Okay. Training accuracy is good, but testing accuracy is compromised.
Is it like we should use decision tree when we have less data?
Decision tree should be using on when you have very too much of data. That means data is very much normalized, and use decision tree with a lot of data, and when max depth is okay. So here you can see here in the decision tree, here you will have max depth. Here you can mention 5. It means the decision tree will have at max 5 depth. Got it, right? This will prevent overfitting. It will not have a lot of questions. It will have important questions. And remember, okay, this is one thing to prevent overfitting. Understood what is decision trees? We'll solve a lot of things using it, but decision tree is mainly important component of any boosting and bagging techniques, which you'll learn in a while. There are a lot of ensemble techniques. Ensemble techniques means you will be combining different weak estimators like decision tree. They are weak algorithms. Okay, like decision tree. You will combine different decision trees and create one grouped algorithm like a ensemble technique. Okay, so I'll come to that. But okay, but you understood it? This thing, decision tree max step, maximum.
Through decision tree, it is used to predict the questions. Which type of questions it is?
Which type of, what is the important questions, and what is each question doing? Each question is breaking down your data into 2 parts, isn't it? Based on each question, your data is grouped into 2 parts, isn't it?
Can we take some small example just without using this data set? Like we can pass our own input and we can predict it, which type of question it is.
No, question. So question is not what you predict. In the earlier example also, right? Okay, let me do this. Make classification. The same thing as.
What is blob?
A blob is like groups, clusters.
We use that in
K-means. I will use that. Number of classes 2. Number of samples.
It is used in unsupervised blobs.
Okay, number of classes to number of samples and number of features. He will ask for a parameter actually here. See here, it needs a number of informative and repetitive. There must be some or some two less than the total number of features. Need 6 features. I mean, that's the, so here this is the data X and this is the target. X, see this is the data. Okay, now if I do this, dt is equal to decision tree classifier max depth 4 dt dot fit. All right, so this is the train model. Now if you do, you see here the value of x0 is less than 0.123 minus 1 minus 0.123. It belongs to this class or this class, right? It is the value of this field.
What is the use of using this decision tree?
Decision tree is a, see here, this is the value, right? So if you, once you have created this tree, what you can do is dt
depth, I think.
Yeah, dot predict. Ask any value here. 4 columns.
Main objective is to get classify the data. Here you decide choosing 2 classes, right? 2 categories.
One,
so which
two,
category
three,
that particular
four.
data is. So based on internally it asks the question,
See?
and then diverts it to which path it will, and ultimately decide that particular record or set of records are which category. 0 or 1 or 0, 1, 2 or
Right, here you have how many classes? 2 classes, right? So you see the output here, 2 classes. So here based on this, see here how it is going. Once that once you do the training, tree is formed, right? After that, see 1.2, 2.2. Okay, you see here 1.2, it goes here, right? Then
minus
less than for minus 0.123. No, it is greater than that, right? So it goes
to yeah.
Okay.
X3 features, 6 features we have chosen. So we are giving 5 features.
No, 6 should be 6. Less than that, it will not work.
1, 2,
1,
3.
2.
Oh, we are giving 6.
Got it, right? So based on now whatever values this guy have it, based on that it will find what is this value. And how it will get it, you will get it from this. Minus 1.2, this goes here. 3. 1, 2, 3, 3. False.
Real-time examples for using this?
Any classification, which is a classification of data which is not linearly separable, where you cannot predict a line which will separate it. That's what it is, right? It's actually asking question. It can separate pretty complex data as well. Okay, and basically your this guide decision trees are used as base algorithm for many advanced technical algorithms. Okay, it is used as base algorithm for many advanced algorithms.
So every algorithm internally it works on this tree kind of thing. It
A
creates
lot of like ensemble technique, your ADA boosting or your random forest works using tree. Okay, decision tree itself didn't become much popular. It combination with different ensemble methods made it popular. Okay, it is alone itself not ever so strong. You'll never find accuracy also too good. I'll show some examples also what is accuracy and all that. But you can see here how it will be calculated. It goes false, it goes here. It is x1 less than minus 2, 3, minus 2. No. It again goes in the left hand side, isn't it? This stage is x3 less than 0.663.
0, 1, 2, 3 is 3.
False, right? It goes here. Right, it goes here.
It ends there.
It ends there, and here it will conclude that the data belongs to class 0 because here is the majority. Right, this is class 0, class 1.
It could not categorize.
It could not categorize further, so it will say whichever is majority, it tells you that. Make sense? Okay, but remember one thing, decision tree alone, I'll use your MNIST data for decision tree from sklearn. Load images, load digits. Okay, now let's see some digits data. It is handwriting data actually. Okay, import matplotlib.
So basically, digits from 0 to.
What does value signify? Which value, Sankalp?
Inside that decision tree.
Oh, that is your Guinea. That is, if that should, we should try, our algorithm will try to bring it as close as 0, right? Because 0 means no entropy, no randomness in the data. All the data are of same type. Your question should be such that 1 should be your answer. Otherwise, you divide the data into half. Namshraj, right? That's why you are okay. Is this the movie in which Shah Rukh Khan acted as a villain? One answer. I mean, it can be as precise as that. Okay. So based on that, okay. Import matplotlib plot.
Did you restrict your decision tree previously?
Yeah, max 5. Yeah. Otherwise, you'll get very.
That is what I was saying.
If you don't restrict, you'll get very huge decision tree. Right, for a small data set, literally small data set like this. Percentage matplotlib inline.
Yeah, what does this load digits data is?
Load digits data, that's what I'm about to show now. Digits.data. 0th data. Let's see. You can see here digits some, okay, do a reshape of 8,8. You can see here 0 here, can you notice? Not so clearly, right?
It's milli or pixels.
This is RGB value, pixel value actually. So if I want to plt.im show, can you see the 0 over here? Right? It's a handwriting digit 0. It is represented in 8x8 image. Understood? Okay, now we'll use decision tree to do the classification.
Okay. Gray. What is the gray?
Color map. C map means gray is color map. Okay. Okay, so from sklearn model-based model selection input.
So are we going to predict whether that data is for which number?
No, we will pass a number here and then you ask it what is that number. I mean, here you can pass it, otherwise you can write handwriting data, pass it over, then it will tell you what is that number. Okay, let's see what happens. So, train X. Test X. Train Y. Test Y. Test it. Digits or data. Okay,
by
digits.
default it's 70 25.
Yeah, so you can see the data is broken down. Use addition tree classifier dt dot fit. Addition tree is classified now. Now let's say find the accuracy. dt dot %. Okay, this is using simple addition tree. What will be the case if I dump my addition tree for this? How many features are there in this data? Because this is the first time we are dealing with images, right? Okay, so how many features are there? Exactly, 64 features. Yeah, each pixel is one feature, isn't it? Remember I told you in pandas, that was the image that we loaded. Each pixel is one feature, right? That is what the case is. Each pixel is one feature, total 64 features. Now,
where we manipulate the depth, while building that model, empty model, or while fitting it? Like where should I restrict the depth of the decision?
No, where before creating the model.
Empty model.
Okay, now this is what we need to addition tree. Addition tree, okay, and do this. You see here, whatever happens, addition tree suffers from overfitting. Did you notice this? And what is this case? This case is your accuracy of training and testing. This is a difference here. Now, to handle this situation, addition tree is a good base algorithm. That means it is a weak algorithm. People call it as a weak algorithm or base estimate. What is the thing now? Okay, because if I didn't give any depth here, right, earlier. Okay, so you anybody wants to see how does this data look like? You can do this. Export graph is dt. See this graph that is getting generated. Right, you can see total number of features is 64, 46, 29, 44. Understood? How is the image actually if you're loading it here? Now, okay, you saw this guy. Now what we want to do is, I want to use, okay, well, I'll solve this problem later also using random forest. So that remember this percentage, 87%. And remember this accuracy. So if you want to reduce this overfitting, what you can do is, maximum, you can mention maximum depth and all that. Okay, training accuracy is very low. Okay, but you can see the difference, maybe number of, difference is very less. Okay, okay, so if you can increase the number of, number of
depth is 3 is low, isn't it?
Very low. So this is, see, it becomes pretty competitive. Okay, so that is where your grid search, you remember grid search. Yeah, we can use grid search.
There is some concept like which we measure like difference between the training data's accuracy and the test data's accuracy. I mean, minimum is the gap is better than
that is overfitting. This concept is overfitting. That's what we're trying to do, right? Okay, understood decision trees. Okay, and of course you can use it for any classification. Okay, it is good when the data is not linearly separable. I mean, data is little jumbled up, data is little difficult to separate. Decision tree access well.
Is there any way by which we can find out which should be the value of max depth?
Like hyperparameter research. That is the one that will find out what is the optimum value here. Now, okay,
6 is the optimum.
We are not getting, huh? Okay. Now we'll quickly discuss another method here, okay, which is like combining these decision trees. That is known as random forest. Okay, might have heard about this. This is very popular algorithm. Decision tree anyway works well if the data is too large. Okay, if data is categorical in nature, right? Decision tree works up well. If it is categorical in nature, decision tree works well. Okay. A few things I will discuss further, but first let's discuss random forest. See, what you saw earlier is, if you pass different order of tree, you're getting different decision trees, right? Different order of data, you're getting different decision trees. So that is what random forest uses. Random forest. Okay, I'll discuss a lot of other things. First, let's see this few concepts here. What random forest does, it combines, it is an ensemble technique. It's an ensemble technique. What is ensemble, right? Ensemble means combining different techniques together to create a new technique. Okay, so what we do, we combine different. So remember, different data means different decision forests, no? A different decision tree, different order of same data means different decision trees. Random forest makes use of multiple decision trees to create a forest. What does random forest? Random forest does is combine different decision trees. Okay, and based on different decision trees, it understands what is the important feature, different thing, right? So, and they based on that, it is like combining different decision trees. So it does not suffer from overfitting. Okay, because you are combining, you are averaging out the trees. You are finding which are the important question and putting them together. Combines different trees to create a forest.
It creates multiple decision trees using the same data sets.
Yeah, and we will combine those important things out of one tree and the tree, because each decision tree does by itself find the important question that brings in the top. So what this forest will do, it will combine those questions.
By doing all this process, what is the use of random forest?
Random forest, again, it is for classification and regression both. Okay, the important thing about random forest, it works with lesser data as well. Okay, and you'll see the previous problem we solved with 85% accuracy, right? Now we'll see solve the same problem. We're expecting it more this time. Understood, right?
With lesser data, it will be difficult to generate different trees.
That is what the good part. Lesser data, you can generate different decision trees. Same data you're using again and again.
We have more data, definitely we can say like we are changing the sequence.
But this random forest works well with lesser data. That's because it is generating multiple combinations of the lesser data to generate a robust tree. Understood, right? So if you have lesser data, your ensemble techniques works well. Okay, so in programming context and all, where you have limited exposure to data, your progress.
Or is it other way around?
No. Not other way around. Decision tree. See, when you have a lot of data, the data automatically normalizes itself. If you have a lot of data, the majority of data will be same, right? Okay, if you have less data, the possibilities of outliers and all those things are very high. In the large data, you can see it will automatically normalize itself. Normalizing, it means if you have very large data, lot of data will belong to same type. The general behavior will be governing. If you talk about 5 people, like we are here 6 to 7 people here, and okay, so we say, okay, let's try to understand the common behavior. It will be different because we have smaller data sets, right? So we might have to try multiple combinations of ours to data. But in decision tree, which is a simple algorithm, but if it is large amount of data, and then we can generalize easily, right? If you have large amount of data, we can get a pattern out of it easily, right? That is why decision tree is good for large amount of data. That's why I said decision. Just keep this in mind. These are generally asked in interviews. If you have smaller data set, which one would you prefer? Because this is, if you don't know this, it will be confusing. Combine different trees to create a forest. Internally uses multiple decision trees I'll use the same things as earlier from sklearn.data sets, import load digits, okay. Now create a random forest model, and all this ensemble technique, right, it takes one parameter and estimators. It tells you how many decision tree you did internally use. All ensemble
This is
technique
a hyper
parameter. rf.fit. Just copy 2 lines from here.
splitting test rate.
Okay. rf.fit. And remember, it is doing multi generating 10 trees, so it will take more time to train actually. Okay. Okay, it will see here, stay anyway happen faster, but random forest is little expensive. I mean, it takes more time to train. Here you can see n jobs is equal to -1 by default. If you want multiple CPUs to be used, you give here n jobs is equal to -1. Okay, n jobs is equal to minus, so that you can make use of multiple cores.
It detects by itself -1.
-1. No, you have to configure it. It will find core and all that. Okay, but you have to configure it, and jobs is equal to -1. Understood, right? A lot of algorithms have this. SVM also have this. Grid search also. I think we did using grid search, right? In grid search, we did used grid search CV. Or anyway, and jobs is for how many times you want to parallelize it. rf dot.
Wow.
See, no changes in the any part of the code. Same thing is giving you 97% accuracy, around 10% more accuracy.
Check with the training data.
Hmm?
It will check with training data. It will be one only. Into the videos. 99.85.
So it is less chances of overfitting, right?
For me, it's 99.
Yeah, so this is fine. I mean, generally, but you'll see random forest suffers less chances of overfitting here. Okay, this is simple data. We'll solve complex problems now. I just explained both the concepts with simple things.
Can we restrict the depth here?
So
every decision tree it will restrict it because it is using different decisions.
Absolutely. Right? On reducing the depth to 6.
Can we see that graph here?
No. Decision tree cannot see.
There are 10.
10 trees and it doesn't allow. I mean, the API itself is not available.
In real world, let's say I have a problem and I ended up using random forest, right? There are, I see like 10 number of different parameters as well. So here we are just using one or two, but most probably like
you might use a few of them. Okay, not all of them.
So when working in a like job or something, we should know all these in depth, right?
Not necessarily. Like, in this case, max features you are telling you want to tell, like, oh, like for example, what is important to tell you? If you have this RF dot feature importance, if you do, it will tell you what are the important pixels in the image. Feature importances. What? Okay, so this is, there are, of course there are infinite things.
Like,
And we understood this thing. This is what this is feature. How many features is it? 64 features. Like if you have 10 columns of data, if you apply random forest on it, and after that you do random forest feature importances, it will give you what are the importance of each feature. Okay, here if you want to know, understood, this is very important.
There is no importance of the first column.
That's all right. Import numpy as in np dot. Nobody is greater than 0.2. Hey.
0.0. If you see that the all are in 0.0.
Oh. Okay, so these are the right. So at least if you something is less than these all features, you think you can skip it. This is feature importance. So you can consider the important features, pixels, and do the training over here.
Like similar to Gini index, there are few other methods, right? I mean, making here we are using Gini as one of the ways. When you scroll up, default is Gini. Class weight none and then criterion equal to Gini. So there are two other ways.
I mean, when it is choosing, making the tree and all that, right? It is using Gini factor. Remember Gini? What was the Gini? It shows the value of randomness. And estimators, we have a criteria. This functions measure the this is what it is actually. Gini. Default is Gini, string optional. Parameter is tree specific. Max features tells you how many features you want to consider. We can pass the list of max features also.
But where we are combining with decision tree? Internally.
Okay, internal different decision trees are combined and you get the result here. Understood? Decision trees? Sorry, decision trees and random forest. Okay, there are a lot of things in ensemble techniques. Just come in 2 minutes. Let's have a 5 minutes break.
Share with you Century AI certificate link. It has few recordings. Internal sessions happens. But they actually they only 10 to 12 sessions. They only recorded. Yeah, I had in this call. Okay, that was awesome. Dhanush. Now I Dhanush. They detailedly explained those answers. Yes, that was the first time I could not understand. Now I'm recording. Yeah, they like the practical. Here it's actually both phases. How many classes? How many sessions they have taken? They took many. I mean, around 10. They even covered deep learning. Even took the bounce learning because again I have to do self practice. I didn't do much. Now I recall those things.
There is a classroom training for that?
No.
Virtual
Skype. Virtual. 2 days a week. 2 months. Those guys are nice actually.
You can apply for that through
my AI में आता है. I'm trying to see again. There is no system. They have Python training. Python. If you want, it's going on actually right now in the third process. Maybe I'll give you link, bookmark it, and once a week keep opening and see if any upcoming training.
We share that link, the recording.
AI circle का link भेजना. चेक उन्होंने एक्चुअली क्या होता है बीच में 2-3 सेशन रिकॉर्ड नहीं किए लास्ट वीक किए बट दे हैव नॉट पब्लिश्ड. So they were saying कि cost of maintaining the recording that cloud में करते हैं ना, it's costlier than just view और नहीं थे. People don't view much. But I feel अगर मुझे अभी होता था तो those missing the theory.
slow again.
Yeah, let's resume back. So what you have seen is, I will solve some problems here, but first let's see some decision tree for regression. Right, we have seen as of now for classification. Let's now see decision tree.
Random forest for regression.
No, decision tree is also for regression, right?
Oh, okay.
Okay, so I just wanted to explain classification first. Then let me explain regression. Okay, now Okay, I have this function make regression. Four features, the number of samples is okay. So this is the target. Understood, right? Regression data we have generated. Now we want to generate this decision tree for that. Then what I should do is train test. Huh? Okay. So you have this X and Y over here. So decision tree for regression. From sklearn dot p import
Between classify and regression.
regression decision tree is trained now. Okay, now also DTR dot score is text. Okay, which is 96%. Huh? Half an hour more. Okay, so here you have. Okay, here you have score part here, but we really want to see the tree and what are the things that changed over here to understand something. But you can see here pretty much this is how you do here. Okay, so let's dump the tree. DTR. It itself took some time, right? That means it's huge tree this time. Okay. See the size of the tree itself here. Okay. Let's have enough courage to open it.
No,
Did you give max length? Max depth?
no.
Actually,
It's 100 kg.
10,000. What? Samples, yeah. What is the number of samples?
1,000.
Huh? 10,000. So you see here, so you have earlier it was Guinea, right? As a feature selector criteria was Guinea earlier by default. Now it has become MSE. What is MSE? Mean squared error. In regression, we have this. How do we find this thing MSE? Okay, let me just plot.
What is it full form?
Mean squared error.
For regression only.
So here you say classification Guinea, right?
It also checks the randomness. This mean square also different.
It also checks the, yeah, but it checks, I'll show it. Take some time, man. Okay, you can see here anyway, it is not generating such a big tree, but we can actually limit the size of it. See, now it has become, I have reduced the size of the tree.
Yeah, no, it's very small.
Right? We can see this time there is MEC. What is MEC? Mean squared error. The actual output, what is mean squared error? Remember linear regression, we did actual output minus predicted output, square of it, sum of the difference, that is your mean square error. Okay, so what it tries to do, it tries to reduce the mean square error to 0, isn't it? Okay, see, start here, the mean square error is 23. If this condition is matching, it is going this side, the mean square error is reducing further and reducing further. These are your leads. Got it, right? This is
it will go to 0.
It will try to go to 0. If it was earlier case history, it was generating as 0. Understood? What is Bayesian tree for regression? It uses the criteria as, see, using Gini also it was trying to make it 0, using root 2 m square. So effectively it's same thing. Right? Okay, so that was Gini concept. This is MSC concept.
But how many different values it will predict? Like in classification, I understand like there are 2, 3, 4, maybe includes, but
Okay, it based on what is the, okay, so here is the value. Here is the value. Right, if somebody matches this thing, okay, so let me keep it open. If you do this, DTR dot predict. Okay. Test X. You see this? What is the value? Minus 71.69.
four features.
This one, right? It will be one of these. Minus 71.615. 71.6147.
So for each value, it will finally conclude because there is no category, right?
There is no category, so it is one of these values. Okay, so here it gets MSC. What is the MSC of this? DTR dot score. I think function was there something.
Unity number
From scalar dot matrices import. Okay, there here you see average precision.
Mean square error.
Mean square error, here it is. Okay. So you do the prediction. ETR dot okay, so here the mean square error is 1174.
We restricted the depth, right? So it may not be.
Not from now. Okay, but based on these techniques, wherever it is bundling up last and operations, it will figure it out what is the regression value.
So is it like, let's say we have 10,000 samples, we will go till 10,000, figure out each and every record, which category. Regression is more like plotting, graph, right?
Yeah, plotting actual tendency. Where is it reaching out to be?
So what we are trying to achieve through decision tree regression.
Through decision tree regression, you are basically trying to ask the right question. Based on that, it can predict the value of it.
Where it will lie on that.
What it will do, for example, okay, like here, for some tree it gets, okay, if x and 0 is less than this, and if this is the MSC value, okay, if this is the current MSC of it, right? If it is less than this, it goes here. If it is not less than that, it goes here. Understood, right? Okay. So whatever data matches this condition x0, if this condition is matched, it comes here. When it comes here, it essentially understands that among the entire data set, 189 samples come here, and the value for this is tentatively this guy. Provided this is the mean square error. Okay, then based on the variation of the mean square error, actual mean square error, from this point, this guy gets out.
The value is nothing but the target, right?
Right, value is the target. Okay, based on how close it is to this particular error, it reaches this guy. Got it, right? Okay. So it is a function of both mean square error and this value. Say anything which matches this condition. Same from top, it matches this condition. How many samples have 110? Does 189 samples have this value? Okay, so let me just show this thing. So suppose you have decision tree. Do this, DTR dot predict train x. Okay, so train x1 is 50.62. This is your first. This one. See 50.16. What is the? Let's hope this is this one. Train y. See, this is the value. This value is 55. Okay, so if you might. Okay, so you can see here it is. It might be checking this. It might be coming this way and finally ending up over here. It's difficult to go through this tree, but it might be coming this way. From here, it might be from here, come here. If you want, we can just map it once. This one, right? Okay. So next, this is x0, right? 0.31. Okay, the most important question starts with x1. 0.86 comes here, right? This is 0.8 minus 0.810. Not visible from there. Yeah. So it comes here. Then it checks for again x1. It is less than, no, it again goes here towards the right. Again it comes here.
x0.
X0. It is less than 0.3. So negative. So it comes here. False. X2.
False, it will go right only.
No. It is less than this, right? It's true. It is true actually, right? Minus.
This is minus.
This is minus.
But there it was plus.
Oh, it was true.
Here we are checking x2.
So this checking x2. X2 is
minus 0.5.
X2 is.
Now it is true.
True, right? It comes here. X0 is less than this. It comes here. See, it is coming here. That's how it reaches this.
50.56. And what is the value?
50.628. And if you see, this is 50.6276. See, it reaches that point. After that, what is the variation actually that MSC finds that out? Some variations after that. Okay, it is a function of both MSC and this guy. Okay, but that is how your decision tree helps you getting the register values over here.
What is trained by 01? Trained by
of this one. Now this is the actual value. This is the predicted value. Got it, right? This is how decision tree does it. Okay. Now one more thing. Random forest, I have to show one more use case of finding the important features. This is very important. This is, remember we did feature selection. Random forest is also one way to do feature selection.
One way to do feature
selection. Using random forest, you can find out what are the important features, and using those important features, you can again train the model. Understood? Using you use random forest first. Find the important columns. For example,
we don't use random forest for regression.
You can use it. Okay. You can use it. You can use same technique. Okay, from sklearn. Okay, so here is the housing data. Okay, this is the shape. 8 columns are there. And this is the price of the house. 4.2 millions and whatever is it. So I'll use decision. With this example, I will use random forest regressor as well as I'll do important features, find important features. Both of them.
8 features.
Huh?
8 features.
8 features you have actually.
Random forest regression we are important.
Random forest
regression we are using.
Because this is a regression problem, right? Target data is continuous. Housing data, your price data is this.
Yes.
Or this is your pricing data. Okay. Therefore, okay, don't kill me for not splitting the data. So now you see, if you do RFR,
estimator equal to 10 years.
Estimator or a number of decision trees it will use. Earlier also we used, right? We combine it. Okay. If you do feature importances, you can see here it is giving you first column is very important. Right, first column is very important. See 0.5. You can see here. First is first, and this guy is important. You can still say these guys, but this guy is very less important. These two guys. Okay. So this is feature importances that you're getting here. So you can now. Okay, let me do one thing.
Sorry to interrupt.
I think I need to show. Tell me.
So in general, like usually we say data scientists should have domain knowledge as well, right? So obviously, I mean, here we are just looking. We are not even looking into the data. We are not understanding it. We are just applying the algorithm, right? But really, like people should be looking into data, trying to understand that. As well,
understand that.
So here we are totally using algorithms to decide which feature is important or not. But real world, like
when you're actually solving the problem, like we'll do on some real data, then we'll actually dig deeper.
We manually need to also look and understand which are really important. Sometimes like algorithm might not. I don't know, but
yeah, for algorithm also you need to build that understanding of building the intuition. How do you choose the algorithm basically? Okay. How do you choose the algorithm? This is what it is.
So there could be many like feature selection, right? Random forest is one of those.
Right. Okay, so here I'll train with the reason I am doing it because I want to compare. Next. Okay, now I really want to compare RFR dot. It is giving you something 77% accuracy. Okay, the root mean square. Now what do I want to do? I want to reduce the number of features. First column I want to use. Then okay, so see here first column and okay, so I definitely don't want to use all the columns from the data.
Probably we can remove second and third and fourth, or
housing data. Okay, so
number of level does not match number of sample.
okay, so basically I want to get those columns. Okay, I'm doing a cheap trick here, so that I can do it quickly. If you do transpose of it, just see, I want some columns. Okay, 8 rows. So what are the row columns I want? Just a cheap trick, don't mind me doing this. So because otherwise I have to convert into pandas and then do it. I want first column, 0th column. I want and last 3 columns. These 4 I don't want. Values are very less, right? 0th column and last 4 columns. So what I can do here is 0th column 1, 2, 3, 4, 5, 6, 7. 5, 6, 7. Okay, I get only those columns. So this is mine. Train X, test X, train Y, test Y. Train X, test Y, then HD, comma, housing target. Okay, you remember I'll be using D, T, R, F, R. Less columns means less amount of CPU required, right? Train X, train Y. Okay, came a little faster. Now let's see the accuracy. Remember, we have only 4 columns here. Isn't it better than the previous one? That is, you understood the importance of feature extraction. Okay, this is the trick part here. I hope you understood what I did over here. Transposed, I need a few columns.
Same accuracy. I'm getting same accuracy, 0.79 in both scenarios.
Did you choose it? Did you train the model again? So even if you're getting the same, you're a winner, right? Because here you're using only 4 features compared to earlier where you're using 8 features. No, on a serious note, when you are creating machine learning models, if both of you are competing and client comes and says you will see which is the more simpler model, who has taken less features into account. Okay, so here was a good case where actually it went well, but even if the other result would have been 76, right, the customer would have preferred the other one because it is a less complex model. Fine. Okay, so next time what we'll discuss more ensemble methods. Okay, more ensemble methods. This was just a beginning of it. We'll discuss ADA boost. Okay, we'll discuss gradient boosting tree, GPT. We'll discuss voting classifier.
Okay, a lot of ensemble techniques we'll discuss. Then
What are those terminologies? Boosting, bootstrap.
Bootstrapping is different. Boosting is that is what we'll discuss next time. These are ADA boost. Okay, GVT, XGBoost. XGBoost is not discussed.
Upload this.
And recording.
Yeah, stop the recording.